All right, so really, y'all, I'm seeing some laptops. We need to keep those laptops on our persons because we've got 40 minutes. If I was talking for 40 minutes, that would be a major problem. We're going to start off with a presentation, but the goal is that as many of y'all as possible can actually, either deploy or interact with the Interop DevNet, assuming Wi-Fi works out. Fingers crossed. That is the goal here. It is to get hands-on. So please do ask questions. But I'll still start off with some start off with some context because, I guess that's important for some people. What is this? Let me just give a little bit. Okay, so we're building out the Superchain. Surprise, surprise. What is the reason? Well, it's not monochain. It's not multi-chain. It is the Superchain. Why is this? Well, it's not monochain because to scale to the globe, we need more than one chain. We need parallelism. We need multiple chains and distribution. And we are currently at the precipice of solving what is the biggest issue in Ethereum today. And that is the fragmentation problem. Now, the fragmentation problem, which you will notice if you go onto your wallet and you try to select a new network, you will notice immediately that it is a horrible experience. The second thing, if you want to deposit a token, you have a choice between this network, that network, the other network. It is chaos. Why is this happening? Why do designers in crypto, why are they so bad? Why are they so bad? Well, it's not the designer's fault, as it turns out. It is our fault as engineers. We have failed the people because our infrastructure makes it very important. When you decide what chain to deposit into, that is a huge decision that you need to inform your user about. Because if they're going to get off of that chain, they're either going to have to wait for an unbelievable amount of time, or they're going to have to pay basis points in fees for their money. So it actually is a meaningful thing if you deposit into chain A, into chain B. Users don't want to have to make that decision. They just want everything to work. So we have bad infrastructure, which results in bad developer tools, bad tooling, and that results in bad designs. And that means that we can't actually get this thing to global scale and global adoption. So thankfully, I'm here with a solution. Good infrastructure, not good tools. We have bad tools. We're still at the infrastructure side. Actually, the infrastructure side is not yet done, but we have a DevNet that we are going to dive into in just a moment. Why, hello. So Superchain enables secure this interop solution that we are, we've talked about for a long time, but we have a DevNet and we are moving to mainnet very soon. It enables secure, zero slippage, one block latency, and cross-chain composability for applications. So this is, what is the basis of solving that DevX problem and solving that UX problem. Now, when I talk about this, I mean, when I say secure, it is the same level of security as a cross-contract call, right? You have an EVM, you have all of these contracts, you can guarantee that as I do a cross-contract call, everything will work out. It's not going to become the case that, this contract fails and then that contract has to react. No, this is protocol level security. And that is what enables you to do things like a mint and burn, bridge, where you literally are trusting that the protocol is working because you already trust that the protocol is working. It's baked into the protocol. And one block latency. This is very nice because you don't have to wait for confirmations. Reorgs are handled in the protocol. Now, one block is actually kind of fake news. Turns out it's actually zero. In the protocol itself, it's actually 0 blocks. In the protocol, we do support like literal same block, atomic composability, enter your meme. But the sequencers do not support that, nor is it really super important to support that on day one. So we say one block latency because it's the realistic thing to say. But if you want to maximize the memes, that atomic cross-chain composability meme that we have talked about a lot, we're doing the thing. We are genuinely doing the thing. So, okay, what exactly, why is this possible? Why is this possible? Well, It's ultimately possible because fork choice is all you need. AKA, when you are actually reading a message on, there's chain B, chain A wants to, read some information. It creates a dependency graph in the protocol. So if chain B were to reorg, or chain A were to reorg, that it propagates throughout the network. So you never end up in a inconsistent state from the perspective of the chain itself. That means that developers do not need to worry about building in reactions to that inconsistent state. And it means that the entire superchain is eventually consistent. So you, from an application developer perspective, can assume that things are happening, atomically, securely, etc. And the network, the magic of the protocol will figure everything else out for you. And that's why you are able to accept a message the moment that it is created, which is what enables one block interop, which is what enables, also zero block interop, as I said earlier. Okay, actually, you know what? I'm going to pause here because this is supposed to be interactive, but I've been in my spiel mode. Do we have any questions about this before, the protocol? I have to do the high level of the protocol before I dive into the actual code. But we will get into the code shortly. Any questions? Any questions? We all know it. We all know it. What is your, oh, heck yeah. Nice. So the question was, what's the difference between intent-based interop and this crazy protocol level native interop? Okay. Intent-based interop, okay, the first way to say it is this protocol level native interop, it works for arbitrary smart contracts and arbitrary applications, whereas intent-based interop really is best suited for token transfers and unifying balances to some extent across large chains. If we drill one step deeper, intent-based interop is essentially creating a way to trigger actions on different chains, but it doesn't enable authenticated reads or writes to different chains. So you can't implement things like a mint burn token bridge. However, this entire system is actually really made much better when we have intents, because actually what's happening here is these reads and writes, these messages that are getting passed, underlying the protocol, there is actually just two transactions, a transaction on chain B and a transaction on chain A, and they're both executing independently of one another. And so the way that you can create a kind of atomic, full, cross-chain experience, which is very seamless to the user, where the user only has to sign one transaction, is actually you generate intents on the source chain that are then fulfilled, and the entire cross-chain interaction is executed, and the fees are paid on the source chain. So in other words, we are integrating very deeply with intents to make this protocol realize its kind of superpowers. But intents broadly are just, they're a different part of the abstraction stack. So anyway, okay, any other questions? For the new people who came in, we are in the, high level understanding of what interop is. And we are going to get into the low level technical depths with your computer. So if you do have a computer, that is amazing, because then we can actually deploy. But again, Superchain Interop, native interop, secure, zero slippage, 1 block latency, actually 0 block latency, but trying to set expectations here. Although actually I feel like we're going to pass. It's called under-promising and over-delivering. Yes? Exactly. So, y'all, we're going to be giving out a lot of hoodies. This is the hoodie factory. Now, I'm going to tell you how to do it. But when we flip the hoodies, I get 5%. That's our deal. That's our deal when you come here. It's only possible with Superchain. I will say, I mean, maybe the thing on this slide that I think is worth noting is this is, in my opinion, humble opinion, the like quote unquote correct way to like build the core protocol interop. And I think we'll see the propagation of these interop solutions evolve. It'll be very, very fun. Okay, cool. So I think that is, to be honest, the end. We are trying to here build an interoperable application. Now, oftentimes there's some questions. Why would one want to build an interoperable application or an application which is available in all of the chains? Well, a couple reasons. One, you get access to the distribution for all of the chains. That is like the primary thing. But two, you also, technically from like I don't know, this is why I originally really liked it, but that distribution is also, it's reflected in the scalability of your application. As we scale up the superchain, if you build your application in a way where it is chain agnostic and it has some kind of superchain awareness, then your application will scale horizontally with every new chain that is deployed. So you're getting to get access to all of these different users, and you're being able to, the whole thing is able to scale. So yeah, this is what we're going to try to build. Now, notably, there's a huge amount of tooling that needs to be built in order for this to be realistic. Contract deployments need to be at standard addresses, create two. If you have your same contracts, but they're all at different addresses on all of these different chains, that is a recipe for absolute disaster. It is, from a user experience, developer experience, you are just going to be sending money to the abyss. And we've actually seen it already happen where hackers squat addresses for people, and it really causes chaos. So they need to be the same addresses. We also are going to need to be able to manage state across all of these chains. So let's get I don't know, let's get crazy. Let's make it like not one to many and more like many to many vibe. Okay, so oh my God, am I gonna sit down? I guess I'm gonna sit down on my lap. Wow, crazy. Okay, yeah, you seem to have a question.
Yeah, no, I just wanted to say walnut guest is the password if people need password for the Wi-Fi. It's tribe guest, and the password is walnut guest, just small letters.
Walnut guest, all lowercase, one word.
And the network is tribe guest.
All right, I need to figure out my own. I need to follow my own link. What is happening here? Here we go. All right, so.
Can we get the URL again?
Yes, indeed. The URL is, go to OP Superchain. It is a GitHub user. That is not me. It is officially not my user. Oh yeah, sorry. Just I'll give y'all even more time. It's OP Superchain. And feel free, honestly, ask me if you forget. Just put the letters OP and then put the letters Superchain. Okay, so here, I don't know, crazy description of native interop. There are some good docs. Please do take a look and give feedback on these docs. There's, lots of really good information about how, you have a source chain that emits a log event. Oh, another piece of note, like a note for the developers. Every event is now verifiable. You can read any event with the interop protocol. So that is actually a very strange property. You are not writing your events probably to be consumed on chain, but they can now be consumed on chain with interop. Little strange, but it's useful. We've got lots of good details, which we won't really get into. Instead, we're going to focus on an example application. So you can use this as a template. You can click the I guess I'll zoom in. I assume we'll need that. You can use it as a template, which will automatically create, a new repository with the Superchain starter. The tutorial is actually pretty simple. Just create a new repository with the template or git clone it into a local directory. Not a big deal. Great. Install the dependencies and literally type in pn pm dev. This will set up a local environment for you to use Interop, with. So I'm going to zoom in. I specifically whipped out my old tmux config so that I can show the developers watching this that I am cool like them. And I'm not a lame person who just uses cursor for everything. I have so many cursor windows. Okay, sorry, but I like the AI. I really do. I really find it quite useful. Oopsies. Here we go. Oh my God. Okay, now this is when I wish I had 3 hands, I guess. Okay. So I just called run dev. All I did, by the way, is pnpmi. Like, it's not rocket science here. What happened here is it pops up this great little kind of UI for just checking out the logs of all of the different services that run when I run npm run dev. So first off, we found that people get confused why this says down. This is not a bad thing. Oh, word. Oh, that's going to make my hell yeah. Gang, gang. Whoa. Hell yeah. All right. Extend the arm. Okay. All right, friends. So maybe I'll just pop around. Okay, great. Fantastic. Okay, so this is bizarre. I feel like a musician. I'm like sitting down, like, okay. So where are we at? First off, deploy contracts. It says down. That's not a bad thing. It just means that you finished deploying the contracts. So the service stopped. Contracts are deployed. Don't worry about it. What does this look like? It's using Super CLI. That is a nice little kind of interactive, or if you want to be interactive, or you can just use it as a binary. And it will deploy the contracts using create2, because we found that there is very bad tooling for deploying contracts. So we're trying to make it better. It will also spin up SuperSim. What is SuperSim? SuperSim is essentially an Ethereum JavaScript-based testnet, which runs 2 testnets. Well, actually 3, technically. It runs in L1, and it runs 2 L2s. So if we look, we've got SuperSim chain 901. We're producing blocks, just as we expect. And by the way, you'll notice, right? Async enable contract was just deployed. All these contracts are being deployed in the blockchain 901. Similarly with chain 902, got a bunch of these contracts that have been deployed. So that is that. And then we've got a front end. And the front end is right here, which we can pop open. And I'll zoom in. What's this front end doing? This front end, it is giving us the ability to either increment. Every good example app is a counter in the Ethereum space for what it's worth. You can either increment directly on your local chain and watch the number increase right over here, or, which boom, it has increased, or I can use a cross-chain message. If I pop this open and I click on that, I can see that I've actually sent an L2 to L2 message on my local machine. So pretty sick. Yes. I like to see it. Love to see it. Love to see the clapping. Fantastic. Okay. So y'all, I hope anyone like download this thing, by the way. Anyone working on it? GitHub link. GitHub link is Ethereum. The GitHub link, the ultimate GitHub link, that is not really. It's my janky GitHub gist, excuse me. Not mine. Someone else's. Unrelated to me. OP Superchain. And then you can see ETHDenver, like whatever gist thing in that link. All right, great. And by the way, please, I genuinely want to help debug issues as they come. So if you're halfway through it, you get cloned and I don't know, it didn't clone, just be like, why did my clone not clone? And I'll like stop and we can talk about it. Because we have 45 minutes. Maybe 45, maybe I'm overestimating how much time 45 minutes is, to be super clear, but I don't know, I just think it's more fun. Like I've done this too many times. I don't need to do it again. Anyway. This is not a production Geth node. However, it is definitely an implementation of a chain, but it takes shortcuts. It's like Ethereum JS. It's like Ganache. I don't know. My terms, they're way out of date. I don't remember. They're Anvil. There we go. That's the word that I was looking for. They're Anvil nodes, actually. That is what they are. They're like modified Anvil nodes. Make sense?
Yeah. I'm just wondering, like, the extent, like, how far along the development process, if I wanted to, could I spin up to actual things?
Aha! Great question. So, in fact, you can. So if you go here to not OP Superchain, Ethereum Optimism, pop this open. Actually, really, you're going to want the dev nets. Anyway, you can absolutely do it. We have kurtosis packages for you to like spin up local instances of the Interop DevNet. And then if you don't want to spin up local instances of the Interop DevNet, turns out we have a live version with a nice little block explorer that you can start playing around with. And you can, send cross-chain transactions. And we have an auto relayer that will just like relay all of the cross-chain messages for you. And so you right here. So yeah, so you can spin it up locally or you can interact with the live version. Live version, here's the status if you are interested. Supports everything from reorgs and like all the core functionality. What is missing from the live version right now is the proof system, still under active development. And we will have the proof system live along with the DevNet very soon. From a developer experience perspective, though, the proof system does not make a difference. It's more about like how secure is your bridge, which in testnet land is not a big deal anyway. So you've got all the functionality here already baked in to the DevNet. Great question. So the chains are literally just called Interop chain, like chain 1 or chain 2. Let me get my route. SID here. It's my address, not my address, someone else's address. If you go and you hover over this, it's alpha 0. And this guy, alpha 0, I guess I'm transacting on alpha 0 a lot. Oh, did I get a nice alpha 1? So this is, I kind of like this block explorer view. It's very much experimental and probably you want to give feedback, honestly, to the block explorer people. But in this world where we're like most of these transactions or many of them are cross-chain and you are interacting with multiple chains at once, it's starting to make much more sense to really like use this view. Like I don't want to see transactions that I made only on alpha 0. Kind of silly. I just want to see all the transactions that my address has made across the superchain. So, any more questions? These are great questions. Keep them coming. Sick. Well, please keep going. We got to give you an NFT. You've got the most questions NFT award. All right. Well, V will give you a sticker. Okay. A star. Sorry, I should. Okay. So next in our little gist, you'll notice. I mean, look, we did Super Sim, and that's really like where probably for now, just like you'll spend most of your time, just like developing locally, etc. However, we can update the Superchain starter to use the DevNet. Now this, I'm not actually sure if you qualify as getting a hoodie just for doing this, but I think you should. I think this is literally all you need. I have supplied the cheat code right here. Remember, 5%. You change these lines, assuming they haven't updated the GitHub repo in between me writing this gist and now. And you can use Interop Alpha. So yeah, it might be a little much to read it here. Just you can, what's it called? Open up the gist. Again, OP Superchain, gist.github.com/OP Superchain. Okay. However, I have, where am I? Where am I? Am I on this branch? Okay, great. So I have already made those changes on a little branch, excuse me. And now I can, if I run dev frontend, I think it's dev:frontend. Classic. Then I go here and I grab that. Notably, I'm not running SuperSim localhost anymore, right? If I pop that open, we've got new chains. These are different chains. These are different chain IDs. And we've got a counter which says 5. That means it's already been deployed. I obviously haven't counted anything yet. If I click increment, should, if the DevNet is live, go to 6. Now it goes to 6 because I sent a increment on my local chain. If it goes to 6, we'll see. We'll see. Exciting stuff. Coming to a front end near you. I just clicked L2 to L2 cross domain messenger, and now that should go to 7. Oh, that's Wi-Fi for you at its best. Wi-Fi at its finest. But yes, look at this. So I'm not actually sure if that one was the interop transaction or if that one was, check it out. So here, increment is very pleasing when these things happen. 38 seconds ago. Sorry, I'll make it bigger. Increment 38 seconds ago. Then I click the other button. So this is a local action on alpha 0. Then I did this send message, right? And that did it go to 7? All right, no, it did not go to 7. Well, fingers crossed, it will go to 7. Bang, bang. Click it again, pray to God. Click it again and pray to God. We'll see, we'll see. Oh, all right. Whew. Wow, yes, thank you. The stars have shined upon us. And so now we are here, we're back. We've sent a bunch of messages, cross-chain messages, 12 seconds ago, 20 seconds ago, 1 minute ago, and we have incremented our counter. Actually, to 8, finally. Man, that auto relayer took its time, took its sweet time. It was trying to play with me. It was, that silly auto relayer sometimes. Sometimes it just messes with you. Okay, so any questions here? I'll pause. This is another moment to pause. So, and yes. Oh my God! What an amazing question. So I can't increase this. Oh my God. Oh, hey, I think I put it in the gist. Did I think ahead? Superchain Explorer. Oh no. Here we go. We're putting it in. It's a comment. It's not me. Someone else commented just now. Okay, yeah. So you can take a look at the bottom of the gist, or you can look not localhost. It is sid.testnet.routescan.io. I don't know what sid means, but we'll see. Cool. By the way, there is a Block Scout interop block explorer as well, which I just happen to not know the link to at this moment, but can probably follow up. But shout out to Block Scout. This is very sick. The fact that we have these block explorers, it's like chains are not real unless there is a block explorer in some weird way. Cool. Any other questions as I pause? Yes. Oh, great. Oh my God. Okay, so I do have a bit of a rant, and I'll try to figure out where to start. To be honest. Okay. Future of chain IDs. Long-term future. They're deterministic based on the chain configuration. So if you know the stack and you know the config, then you can deterministically generate the chain ID. Because chain IDs today are NFTs. You need to look them up in a registry. They're like kind of a swag, you know, like cool kid. You know, I hold this like I got number 10. You know, we had number 10. The reason why we had number 10 is because they weirdly sorted the chain IDs so that it was like 1 and then 10 was like right after 1. This is like a bizarre sorting on the chain ID website. So we picked up 10 so we could be right after Ethereum mainnet. So like that kind of stuff. Cool for like 2020, I guess. Not cool in the future. Chain IDs need to be abstracted away. There are some interesting things. So the way that I see it is you're going to have 2 sets of chain IDs. You're going to have the NFT chain IDs, which are pointers to the real chain IDs, which are deterministically generated based on the chain configuration. So they don't change. They're content addressable. That allows you to then, if you are able to sync the chain, you by definition have the chain ID. And you don't need to like look up, you know, grab a registry and like do a key value mapping, all that kind of stuff. But you should be able to sign both. Anyway, bit of a rabbit hole, but that I think is the future of chain IDs. Absolutely. Hashes for chain IDs. Like the whole chain ID thing, to shorten it, was like to 64 bits if I remember. NGMI. Very bad. Horrible idea. We need to kill that. It's like saying that we need to keep chain IDs as NFTs for the rest of our lives. Sounds horrible. Let's just make it. It's like we want to introduce IPv4. We have IPv6. Let's do IPv4 now. It's like, no, please don't. Okay, sorry. Next question. Oh my God. Who's doing it? Who? Raise your hand. Hey, let's go. Let's go. You did it. I mean, look at that. That's insane. That's psychotic. What the fuck? Well, I'm getting your numbers. I don't know. I think the Wi-Fi is a little funky. But that's impressive. That's very sick. So that means, what the heck does that mean? Where the heck? I don't even remember. I don't know the address. Oh, thank God there's an address. Let's look at the block explorer. It's not real if it's not in a block explorer. Internal transactions, presumably. Boom. All right, now we're gonna dox your address. Live on TV. We got this beautiful address here. I pray to God this is not your main, I hope. Okay, no. Maybe I pulled it up wrong. All right, so that's good. That's good. Look, it's impossible not to dox. By the way, for the hackers out here, this is not my normal setup. So you don't even try. Don't even try. You're not getting any alpha from here. Okay, what the heck am I doing? Okay, great. That's amazing. 16. Holy cow. Who's the next one? We got number 1. Who's going to be number 2? Hey, let's go. Let's go. We got number 2. Keep them coming. Keep them incrementing. We're actually going to do like a tug of war, I think, in the next session or something, which will be very sick. Y'all are going to be ready for that. Yeah, start writing scripts, you know, get your scripts ready. Cuz you know. That's the thing. Okay, so I will just say that Ethereum was incredibly magical back in 2016, 2017, whatever, because it was insanely cheap and you could throw real stupid stuff on chain, like really dumb things, and you didn't have to think very hard. Then everyone did a very simple math calculation, which is if I do 15 dumb things per second, then everything gets impossible for me to do and it all breaks. That started a very large quest, which has dominated my waking hours, for better or for worse, to solve that one issue. And I really think that we are getting back to the point very soon. If we get the tooling to be good, then you build your smart contract in a way where it's available on all of the chains. The moment that you want that smart contract to be on that chain, anyone can permissionlessly deploy it because it's create to, it's not a permissioned deployment. Therefore, as we scale up the number of chains, the amount of dumb things per second that you want to do scales up with it. And so if we think the superchain can scale up to, you know, 1 million TPS, like we can do an incredible amount of dumb things and we can bring it back. So I don't know. That would be that's like, I'm genuinely so pumped for this. Did that make sense? Because it includes the words create to, which unfortunately is not self-explanatory. It's obviously not create one, but what does that tell you? You know what I mean? Anyway, but did that make sense? Sick. All right, we got a smart crew. I guess these are the people who've figured out how to increment my counter remotely. Sick. All right. I mean, oh yeah, sorry. All right. With that, I will move on to the more Rambo part of this GitHub gist. So, the Rambo part of this GitHub gist is right here. Doop doop. Actually, first, I think it's a good idea for me to just talk a little bit about, you know, where, you know, what can be done. So first off, where are we in like the life cycle of Interop? We are in the very first stage where there is just the core primitives that did not exist before that now exist. And what that ultimately means is that we can get things like, you know, the Superchain starter together pretty easily. You get clone. It's like pretty repeatable. But if you want to venture out and do your own application, you are going to immediately find that there's a bunch of annoying things that you will have to deal with. So if I go to, you know, this like futuristic Superchain starter, which is in the GitHub, although I obviously didn't include a GitHub link, which is a little short-sighted of me. But if I go here to OP Superchain on GitHub, I can see this, and this is not really good or secure code, but it's more just interesting to see and to think about the possibilities of what tooling could exist in the future. Okay, so I want to start off with something that many people know from JavaScript land. Maybe they love it. Maybe they hate it. They're probably somewhere in between. Just promises. We are moving into a world of Solidity being fully synchronous and only having synchronous syntax to being in a world where Solidity needs to be able to react to callbacks, needs to be able to register callbacks, needs to be able to send messages asynchronously and, you know, proceed. So this is an implementation. Now, it's not a modification to Solidity. We can get really fancy and we can like hack the Solidity compiler and like build out like proper promise support in a kind of cool way, maybe even async await. So these are definitely like projects, weekend projects that y'all can work on, which would be very cool. Please post about it and, you know, get some retro funding or something. This is a kind of crazy hacked version of it where you essentially create a pointer, which is local to the chain, to a remote contract. And this contract is at the address of the current contract. So we're, you know, pointing at a version of myself in a you know, distant location, which, by the way, I think this is going to be the pattern. You end up writing your smart contract as a kind of fleet of contracts that are available on all of the chains, all at the same address, because it's all create to. So you have a quick and easy authentication scheme. Like, I know that my version on chain A can trust my version on chain B. Obvious example of this is a token. I have a token contract on chain A. I have a token contract on chain B at the same address. If I burn tokens on chain A, I can mint tokens on chain B. No one else can mint tokens on chain B, but I know I trust myself. So we can start building out these kind of this is a mental model for parallelism. It's not, I wouldn't say it's maybe the most intuitive, but it's not bad and it works in the context of the EVM pretty well. So I've got a version of myself over here, and I have specified, sorry, this is that new GitHub UI stuff. I specify my target chain ID. So now it's a remote instance of myself on a different chain. I call an async function. Now this cross-chain increment has an async modifier, which actually doesn't do anything. If you look into the library, it's a little, it's, you know, just syntactic, like it's like tells the, I won't even get into it. It's a hack. And then I can do a .then and register a proper promise, which is kind of sick. And so in this case, we just like increment a remote, you know, we emit an event after the remote chain has incremented its counter. So it's an implementation of what we saw before, but just like a little more futuristic, a little crazier. I'm gonna pause here, and yeah, y'all have any questions? Wow, we're low. We live on the edge here in ETHDenver. Yes, I would love a little battery. See, this is community at its finest, right? This is interoperability. This is the superchain. Okay, yes. Ah, great. I love that. That is my favorite question because turns out it receives it right here. It's the same contract at both chains. Yes.
You mentioned a relayer.
Today, it is just a centralized relayer. The goal is for this relayer to be an intent, like open intent-based relayer, which allows you to then relay any transaction, or anyone can relay transactions. Anyone can relay transactions right now. We're just like running a centralized one. But as the kind of intent solvers become more and more, there's more and more of them, more and more people can relay these transactions for you. So it should be an open, you know, relay network.
So the relay is essentially just listening and then posting.
Yeah, exactly. Literally. It's literally just listening for events. It's like, hey, you know, someone will pay me an ETH to relay this event. And then they go and they relay the event and then they pay the fee. Pretty simple. Not it's a very, very dumb, very, very simple thing. And specifically, they are relaying events from the, you know, from Optimism. Oh man, I don't have my Vim, you know, Vimium. There we go. Okay. They are relaying specifically from L2 to L2. See, if you're like, oh, you judge people for not using TMUX, but you don't use Vimium, what are you doing? You know, you're pretty lame. Okay. Yeah, so they're looking at this this L2 to L2 cross-domain messenger for outbound messages. And there's a send message function here, which gives you a destination chain, a target, and some bytes. Yep. Oh, thank you. I was like looking for that button and I was like, what the heck? Yeah, I see a button and I do see a little blinker, but I don't see a lot of juice. Yeah. I mean, I accept all forms of power.
You are coming up to the end of your story. I think you can.
You're right.
It gives you a bit of extra
All right.
adrenaline to finish.
You're right. This is the end. It's no. Here. Let's go through one last thing that I think is going to be very interesting. This is the beginning. You're right. What am I saying? I'm so down. I'm so pessimistic. Ugh. Okay. Last thing that I want to show y'all is this. Okay. Get super contract. All right. So I created a competitor to VM. Oh my God. It's way better. No, I'm just kidding. It's real bad. But the point is, it shows you that there are kind of cool patterns that we are missing out on in our developer tools. So here, get super contract. What the heck is a super contract? That is psychotic. Well, if I use VM, I currently create one like JavaScript instance that is a pointer to one contract deployed on one chain. That means, I mean, it makes sense. EVM you deploy a contract to Ethereum, you interact with it, you want to have bindings and all the kind of good stuff, syntactic sugar for sending transactions that target that contract. It makes a ton of sense. In the Superchain context, I don't want to think about each individual contract as a distinct entity that I have to manage. Because I'm gonna have so many of them in my front end, I'm gonna be able to access any of these chains. I want to be able to access my contract anywhere. And so what I'm doing here is I am creating a new, super contract with a particular bytecode, and from there I can literally start making calls, ETH call, that kind of thing. I know people say like read and they call it a bunch of different things. I'm just calling it an ETH call. Or I can legit send transactions. But when I do these things, call or send transaction, I'm going to be specifying what chain ID I am interacting with. This is because my instance of my contract is, and I'm going to use horrible words, counterfactually available on all of the chains. It's counterfactually deployed on all of the chains. I didn't need to send a transaction because I'm going to assume that every time I want to send a transaction to a contract that's on a chain that for whatever reason that contract has not yet been deployed, the first thing that's going to happen is it's just going to install the contract. And I use the word install very intentionally because it's taking this bytecode and it's installing it on a chain, and you know where it is, and then I'm going to send the transaction, or I'm going to make the call. And I, in fact, think that this install pattern, instead of deploy, like it's install over deploy, maybe that's, actually, I'm going to change some terms. Okay, that's cool. Fuck. Okay, but even for cross-chain interactions, right? We looked at that. Oh man, I was somewhere else. But we looked at that cross-chain call right here, and one of the things that's messed up a little bit about what I did here, to be honest, is that I am creating this remote, this async proxy, and I'm calling this cross-chain increment with a promise, but it might not have been deployed yet or installed yet on that remote chain, and so I don't want to be thinking about the fact that my contracts I don't want to be like, oh, it's over here, but it's not over there. And I have to like call this deploy before I call this thing. It's a huge amount of cognitive overhead that is not necessary. So really what I want to do is, even in my tooling in Solidity, it knows that if it makes a call to a new chain, first it'll check, all right, is the contract installed yet? Yes. Okay, great. Let's send it forward. Or it's not installed. Let's just install it real quick. Yes, installation takes a little bit more gas than a normal transaction, but it's not super meaningful because we're scaling, baby. That's the real thing. So with that, last thing I will say, and I said this in ETHDenver, but I just want you to know, Interop is the greenfield. Now, you might think AI agents are the greenfield. They would tell you that, wouldn't they? They say it. But, in fact, disagree. I think Interop is the greenfield, at least for extremely nerdy VM, language, dev tool, Ethereum, just like deep, you're like kind of an Ethereum nerd. This is the place to be because there is a huge amount of stuff that is incredibly, incredibly terrible. Now, in my previous session, I said you can be pretty dumb to make a paradigm-shifting achievement, like the best developer tool of a new category. I've been told that calling people dumb is not good. I just want to clarify. I consider myself extremely dumb. I'm not going to be able to outcompete the masses of people coming up with genius ideas in very popular areas. This is called being a big fish in a small pond. I used this very intentionally in 2016. I was like, oh, this is a small pond. I could be a relatively big fish. I'm a very small fish now in the big pond of crypto and the big pond of Ethereum. This is a moment to become a big fish. It's not by growing, because we know that's really hard to do. It's by finding a different pond. Or in this case, a green field. And with that, yeah, hit us up. Thank you.